Hi everybody, I hope you can hear me. My name's Jordan and I'm making this short 3 to 5 minute video as a kind of demonstration, a lecture, or even better, an idea of what a lecture could include, what it could be like. And this style is quite consistent with a method that I've used before when teaching undergrad students, but of course the content is modified a little bit for a high school audience. And I'm using Panopto software to record this, which means that I can share the screen. And that's something that I could do. Also, you can screen share with Zoom or Skype or some other video platform. So as is clear from my application, I'm a marine biologist. I could teach on a bunch of different things, but one of the lessons that I could give would be like a Marine Biology 101. And I think I would prefer to do that in terms of introducing the audience, the students, to the wide range of creatures that you can find in the sea. In fact, there's a lot of unknown or species that are unknown to the general public and to students. The word plankton, for example, is a word that a lot of people have heard from, for example, SpongeBob SquarePants, but they don't necessarily know what it is. Everybody might think that plankton, which is really my area of expertise, are creatures that are generally really tiny that you can't see. But that's not the case. In fact, you can have some massive, massive plankton, including the oceanic sunfish, which is the largest bony fish in the world, or massive jellyfish. And that's because the word plankton just means a creature that can't swim against the ocean currents. It doesn't really have much to do with size. So one of the things you can see, for example, here, if you type into Google animal kingdom phylogenetic tree, don't worry too much about this complex word, but this is just a family tree showing how different types of animals might connect to each other. So what you're kind of seeing on the right hand side of this diagram here, okay, and we can make this image bigger so you can see it better. Okay, these are the chordates. So these are the creatures that have something like a backbone, and we are in that group. So this includes a lot of the things that we see on a daily basis, your mammals, your birds, your reptiles, and your fish. And these are actually are really recent members of the family. They evolved a long time after some other types of animals, okay, such as your sponges, which is a very basic creature but still exists today, and all your creatures that sting, for example, jellyfish and corals. So it's very important to learn about how these animals came to be, why they're still here today, and what they have in common. Okay, so you find that kind of the most basic animals, primitive ones, have this kind of like circular or radial symmetry. But as we get towards more recent times, there seems to be an evolution of a kind of more sausage shape, and there's reasons for that. Now, adaptations of creatures to live in the sea is something I really love and care about. So that is something I would focus on in my lectures. For example, behavioral adaptations. And I gave a lecture before in 2020, again for undergrad students, but this can be modified. And in fact, it doesn't really need to be modified too much because a lot of the basic principles are not particularly difficult to understand. They're just not talked about very often, but they can be related to the audience quite easily. So in migration, animals migrate, and a lot of people are familiar with bird migrations, but a lot of species migrate, okay? And they do it because they need to or because there's just a benefit of doing it. Some creatures, such as birds, actually fly, certain birds, the Arctic tern is a key one, fly massive distances, including in this case from the Arctic to the Antarctic every single year. Now, why would it do that? It's a massive, what seems to be a massive energy cost, but in fact it's very, very beneficial because it lives in a perpetual summer, okay? Which means that obviously the poles immerse themselves into these long days in the summertime and long nights in the wintertime. And this species really benefits from the period of summer because there's more food for it at that time, and it'll really want to escape the winter. Fortunately, it can move from pole to pole because it has its summer at the opposite side of the year. So that's definitely something that I would talk about. And again, like I said in my application, discuss this with the students because these are subjects that most students can relate to. this app is one that shows data. Okay, so we actually have COVID cases here from different parts of Scotland. You can see the applications of that for marine biology communication. But of course, these apps could do a bunch of different things. And I would love the students just to start thinking about what they could use apps for. So I guess that's a good introduction to what I would be talking about here, or what I could lecture on. These would be flexible lectures. Well, actually, hopefully they could go over a 4-week period. Maybe I could run 2 classes, the first one being this coding class, and the other one being a marine biology class, marine biology, animals, creatures. And so these 2 classes would run concurrently over a 4-week period. And then we'll just take it from there. There's obviously 102 marine biology, 103 marine biology. A lot of this would be taking marine biology bigger, okay? So marine biology is actually related to every other science you can study: geology, chemistry, physics. Perfect example is a plankton moves with the ocean currents, so learning about the currents is important. Ocean acidification and anything related to climate change clearly has a chemical aspect to it. So the chemistry is affecting the biology. And so hopefully we'll take it from there. And hopefully that's enough to introduce myself into what I could talk about. Thank you.